Welcome back to lesson U2A5. We're going to take a look at parallel and perpendicular planes. We're going to say that two planes, pi 1 and pi 2, are perpendicular to each other if their normals make a 90-degree angle. If two normals make a 90-degree angle, it means that their dot product must equal 0. Similarly, we're going to say that two planes, pi 1 and pi 2, are parallel to each other if their normals are parallel to each other. And if two vectors, or these two normals, are parallel to each other, that means they can be expressed as scalar multiples of each other. So if we want to prove that two planes are parallel, it's enough that we prove that the normals are scalar multiples of each other. So we're going to take a look at example 4 first. We're given the equations of two planes, plane pi 1 and pi 2. And both planes are given in scalar form. And we want to show that the two planes are perpendicular. So first we'll identify the normal of the first plane. That's 2, -3, 1. The normal of the second plane is 4, -3, and -17. So let's find the dot product of these two vectors to see what we get. We have 2, -3, 1 multiplied by 4, -3, -17. So obviously the x's together, the y's go together, and then the z's together. So let's get started. We have 2 times 4, 8. -3 times -3 is a 9. 1 times -17, -17. 8 plus 9 minus 17 is 0. So therefore, we'll say that n1 dot n2 equals 0, which tells us that the plane pi 1 is perpendicular to plane pi 2. In the next example, we have to show that the planes pi 3 and pi 4 are parallel, but not coincident. So here goes the third plane, and this is plane 4. So we're going to start off by identifying their normals. So 2, -3, and 1 for pi 3. I'm going to call this the normal n3 just to comply with the name for the plane itself, and the normal n4. So that's 4, -6, and 2. So if I want to check whether the two vectors are scalar multiples of each other, I find the ratios of the two. So in this case, I'm going to start off with n3 in the numerator. It doesn't really matter what order we use. So we have 2, -3, and 1. And here we have 4 and -6 and 2. And as you can see here, we are comparing the x's together. So it seems that we have a 1/2 ratio. -3, -6, that's another half ratio, and then a half as well. So we're going to say that we have 2, -3, and 1 for n1. And for n2, we have double of 2, -3, and 1, which tells us that we have a ratio of 1/2. So that means that vector n4 equals 2 vector n3, right? So you can put it this way. So bring the vectors closer, and you can look at it by just cross multiplying. So 1 times n4 equals 2 n3. So therefore, we're going to say that the vectors, the normals, are scalar multiples of each other, which makes plane pi 3 parallel to plane pi 4. So this is the last part of the lesson, finding angles between intersecting planes. Now remember that if you want to find the angle made between two planes, it's enough that we find the angle made between their normals. And the angle made between the normals would be easily found by using the dot product. Obviously, you can use a cross product as well, but that is a more kind of a lengthier process. So let's take a look at example 5. We are given two planes in scalar form, pi 1 and pi 2. And we have to find the angle made between the two, which means we need to find the angle made between their normals. So let's find the normals first. So 1, -1, -2. And normal N2 would be 2, and then 1, and then -1. We're going to say that the angle made between these two normals can be found by the dot product formula, which is magnitude of N1 now, magnitude of N2, and then cosine angle theta. So N1 dot N2 is 1, -1, -2, dotting to 1, -1, equals magnitude of N1 would be the square root of 1 squared plus -1 squared plus -2 squared. The magnitude of N2 is 2 squared plus 1 squared plus -1 squared times cos theta. So again, here we're multiplying x's together. 1 times 2, 2. Y's together. -1 times -1 is -1. And z's together. -2 and -1 is +2. So this would equal 1 plus 1 plus 4. So that's a 6. And 2 plus 1 plus 1, that's another 6. So that's cos theta. And we have 2, 4, minus 1, 3 equals root 6 times root 6. That would be 6 cos theta. So that makes cos theta equal to 3 over 6 or 1 over 2, which makes angle theta equal to inverse cos 1 over 2. And that would be the angle 60 degrees. So the two planes will make an angle of 60 degrees with one another.